Hello, my name is Hakon and welcome back to my channel and a little look at the latest development of my modular synthesizer expansion project, proper DIY stuff. Last time I showed you the panels, which I now have printed on poster board, printable dual-sided poster board, which isn't the ideal material for these panels. One thing I noticed when I varnished the front to make it more durable, the whole panel curves like this. So it's got a little curve on it. So I was wondering if there were any ways I could bend it back or push it from the back to make it more stable. It's not a big deal though. I don't think, because most of these banana jacks are also quite easy to plug into. I don't think it requires so much force that it will be a problem once these modules have been attached to the rails. Just an observation. Now, it's of course, as a DIY project, this is the easiest way for me to do it. It's both the easiest material for me to print, cut, and put holes in. So since last time I've made all the holes, and as you can see, if you look closely, some of them are a little bit off, but not hugely, and it doesn't glaringly look at you just like the LEDs from last time on the dual attenuator prototype. And I wired up most of these now as well. So I've got two dual attenuators now. So this is the old one that I've just transferred to a new board. Nice and smooth main pot there. So that's the old one, and this is the new one, and it's a little bit tidier, the new one. You can see I put a little Vero board there on the LEDs. It's a little bit easier to wire it up, and also I put a little Vero board strip here for the ground connection as well. It's a temporary thing, possibly. I've got some different ideas for ground, but I'll talk about that in a moment. I got my passive attenuator, which is just a set of 8 passive attenuators. So this is a single attenuator, but the idea is that a single signal, which could be from both of these, goes first through a variable resistor. So it reduces the entire signal, and then each or that one goes into 2 different potentiometers that can each vary the signal separately, so that these 2 outputs will move in parallel when you move this one. So it's a playable dual attenuator. And also the LEDs, when switched on, will also attenuate the signal a bit, which is why I've got a switch for that. In case if I want to use the full range, I will switch it off. If I want to use a smaller range, I will switch it on. And that will also give me visual feedback: red for negative voltage, green for positive voltage. So that's the dual attenuators. This one is nice and simple, and as you can see here, because the components are quite close together, the potentiometers are squashed almost up next to the banana jacks. So just to be 100% sure that there would be no short circuits, even though the middle leg there is the one that actually goes to the banana jack next to it, I put a little piece of poster board, just squashed it in between the banana jacks and the potentiometers like this. So the inputs are the black jacks and the outputs are the colored jacks. So the inputs go in here on this leg of the potentiometer. Middle leg is the output, goes to the colored jack, and the left leg here is the ground connection, which goes to the Vero board strip. Very simple construction. The landscape stereo field, there's lots of wires, and I just join the wires on the Vero board just to keep things a little bit tidier. So the principle of it is that this mimics exactly the layout of the landscape stereo field. So the outputs are on top and then the inputs on the bottom, and likewise for these. And the outputs, of course, from the landscape stereo field are attenuated. So these connections here, it comes from the landscape stereo field into the potentiometers, and then it goes to the output jacks. So these can attenuate the signal going out of the landscape stereo field, just like the potentiometer on the landscape stereo field itself, except that is a single one for both outputs. And then the inputs from the phenol or wherever else that goes into here, it goes in here and then through the potentiometers and can be attenuated, and then it goes to the stereo field. And then it's the same for the right channel. And then I've color-coded the cables. So this is red, blue, green, and yellow, and together with a black cable. So you can see I've paired them up here. So this is the red and black here, which means these are these two cables here. And that's so I can make sure that I plug them in the right sockets on the landscape stereo field. So these are connections from this panel is connected to the stereo field via the mini jacks. So that works really well, I hope. I haven't tested this, but all the solders are good. All the connections are good. I've made sure there are no short circuits when I've been doing this, so I haven't tested anything beyond making sure of that. So this one looks the most complex, but it's just because there are so many channels now. So there are 12 channels of CV output, and there are 5 gates and a clock as well. And then there's an on-off switch for the filter, and I'll tell you a little bit about that in a moment. So the signals from the MIDI muso go via these pin header connectors, and which I've sort of labeled with the name of the pin header, B, C, and D on the MIDI muso, and also I've marked which corner is the ground connection. That's the one here. And then the ones from the gate pin header will go to this bit. So they will go first into the LEDs and then into the potentiometers for attenuation, and then to the gates. If I use them just as gates, then I don't need to use the potentiometers, but if I use the potentiometers, I can give them different voltages and I can actually do more with them. So that's going to be interesting to see how I can use that creatively when I'm playing. The 2 pin connectors from the other headers go into these ones. Of course, this is numerical order. These ones from the MIDI muso is not in numerical order, so I'll have to make sure I'll get them all in the right place. And the theory here is that each of the connections from the MIDI muso will first go into a low-pass filter. So this is a really weak low-pass filter. It is a 100 ohm resistor into a capacitor, and the capacitor is connected to ground. So this strip in the middle there is going to be a ground connection. So each of the inputs here will be connected to the connections from the MIDI muso, and the outputs will be connected to the attenuators, and the attenuators will be connected to the jacks. And the reason is, and of course the ground connection from the filter will then be connected to ground, but only via the switch here. So I can switch that off. And what that does when the switch is off, when the voltage is only 128 discrete values when it is from MIDI, which can sound really digital. So if I wanted to sound digital and a bit sort of gritty, I'll leave the switch off. But if I want to smooth it out, I can put the switch on, and this should be, theoretically, I did a little test, about the right amount of filtering to smooth out the sound without delaying it too much. So if you put too much of a potential or a capacitor in this kind of setup, you get a really sort of slow lag from, if you increase the value, it will take ages to actually go up. So that is the idea behind this design. It will slow it down just a tiny bit, enough to create a more smooth signal. So you get smooth envelopes, smooth LFOs, etc. coming out of the MIDI output. And this is, of course, something that is usually included in normal MIDI to CV modules, except usually you wouldn't have a switch to switch them off. Normally it would just be integrated into the setup and you wouldn't even know it was there. So, but because I'm making this myself from scratch, I have to also make that as part of my project, and it makes a huge difference to the sound. And because I have a switch now, it will be also easy for me to demonstrate the difference when I set this up and try it for you one day. So that is the design there. So lots of wires still needing to be done here. So that means that several of these wires now they are going to go into this Vero board here, and of course these wires here, the ones from the gates will go into this Vero board over here with the LEDs, and the two other ones will go into this Vero board here. And then there will be a ground connection, which I probably will also put on this Vero board here. So there's one ground connection for the capacitors, and that will go to the switch. And then there's another ground connection, which is for the potentiometers, which I will join together with this one and the other ones at some point. So now the idea I had with the ground connections was that I would make something like a little sort of bank or a little module that will be on the back or somewhere on the synth stand itself that has banana jacks. And so we'll connect cables from each of these modules. So each of them will have a soldered cable that is connected with a banana jack on the other end. And that banana jack can then be plugged into the ground module. And also I can connect the ground from the phenols, and I will connect the ground from the MIDI muso itself, of course, needs the ground connection. Although that might go via this MIDI interface here, and they can all be plugged in here. The ground connection from the landscape stereo field, I will probably also go via this interface here. So what I've done, there's an extra cable here which is white, and that is going to be the ground connection. The way I'm thinking of doing it is I'll split this white cable into 8 cables, so that each of the mini jack plugs that I'm using can actually have a ground connection, so that I don't have to plug them all in at the same time if I don't want to. So that means I can actually unplug them, and as long as I plug in one of them, I will have got my ground connection. Otherwise, it would behave slightly differently, because the cable connections on the landscape stereo field aren't just connections, they also are switches. So they change the signal flow inside the landscape stereo field. Sometimes I may just want to plug one plug in, and then I want that plug to also have ground. Otherwise, I would have had to add a separate ground connection to the stereo field in some way, either from the chassis probably. So yeah, it's not, which wouldn't be as convenient, because then it would always need to be plugged into the ground of the whole system. But this way, it only needs to be plugged in when I need it to, which is when I'm using the interface and I plug in a mini jack. I hope that's clear. It will be more apparent, and I'll talk about it again, of course, when I demonstrate the finished product. That is, I think, all I wanted to say today about this. I'm quite happy with the way this looks now, because of these panels, when you varnish them, they get a bit twisted. And also sometimes the potentiometers are a little bit askew, because now these are all askew in the same direction, and these are all askew in the same direction. But when I mounted these first time, I actually had them pointing different ways, because I was trying to point these ones to that direction to have more space in the middle for some kind of strut to prevent the curve. but that didn't look nice. This one looks a little bit wonky now because these ones are pointing that way and these ones are pointing that way. Not a big deal, but it is something that I maybe will try fixing at some point. Now, of course, this is all really sort of a simple way of doing it without having proper front panels or anything like that, or proper PCBs. It's just really sort of done as a hobby project for a very beginner when it comes to electronics. So if I were to do something like this properly one day, I would get aluminium panels made. I would design PCBs that would allow me to wire these things up perfectly and neatly, and the PCBs would sort of be behind here somewhere, and you wouldn't have such a mess as these. But all of these are going to work, and they're going to work well, and I will have learned quite a lot from doing this. Oh yes, another thing that I did learn actually along the way now. So if you see these little lugs that are attached to the banana jacks, I'm not sure if I mentioned this before, but when you get the banana jacks, you can take the lugs off and you can put them on, which is quite useful. Some banana jacks, the better quality ones, they tend to have a permanent fixing, so you have to solder it up, and that's it in place, which is better in many ways, to be honest. But the thing is, if you get the cheap ones with the lugs, the little, I'll show you actually, if I can find one. Okay, so this is how they come. So there's a little nut there, and then there's this lug here. So these lugs, when they're new, they are actually, I would call them solder repellent. So it's almost like you have to burn off the surface of the metal to make the solder stick. Otherwise it beads, it runs off. It is absolutely terrible to work with. But what I found, I had a theory. I did try using sort of denatured spirits and things to clean it up, or technical spirits. What I'm using is a file like so, and I just scratch up the entire surface until it is completely scratched up, like so. So you can just see it's all scratches. And then when you solder it, it works really well. So that is a little tip for you. Get a little file, scratch it up. It works wonders, and it's so much easier to do than otherwise. But because these jacks have a separate solder lug now, it's easy to solder up, because I have these lengths of wire, and I just take the wire, I put tin on it, and I put it in my helping hand. Got one of these things here, which is really useful when you're soldering. So I'll just put the lug on one side like this, and then the cable on the other side, and it's easy to solder up. Very useful. So this is a very useful little thing. I think it's called helping hand. I've got a magnifying glass, which I don't use because I don't need it. My vision is still quite good, thank you very much. But yeah, I could remove it actually. Otherwise these are very useful. You can rotate them, move them in all kinds of directions, and it is so useful when you're soldering. Right, so I think that is about it for today. So this is the current status of my project. It is moving along, and it's going to be absolutely epic when it is done. It's going to look nice, and it's going to work really well, I think, and it will give me a lot of new options for how to play my phenol synthesizers, and it's going to be very enjoyable, I think, because these are things that I've been thinking have been missing from my synth. And yeah, it'll just be so nice to be able to do more. Yeah. So if you have any questions about how any of this works, just please leave it in the comments. If you enjoy this, also please like, share, comment, subscribe, join me on Patreon, all those things. And I will see you in my next episode, where I will probably have gone a bit further. I probably will have finished my MIDI interface, and I will probably have attached all of these to the frame, and I will probably get to making the stand. Oh, that's one more thing actually that I was thinking of. Now, because this frame here is wider, if you look at this, it is wider than the synthesizer. And I was thinking, oh, that means I would have to put the end cheeks over here, and there'll be a bit of a gap. But I got a good idea yesterday, and that is I can let the frame actually go into the end cheeks, or even all the way to be flush with the end cheeks on the outside, because that will allow me to get a nice stand that actually is going to look much nicer for the phenols. So I would have end cheeks that stick out, maybe the same as the Eurorack rails. And then I will just make an indent in that and attach it to it in a different way, but it doesn't need to be attached very firmly or anything, so it's going to be quite easy to improvise something that will work. Worst case scenario, there will be a little bit of metal showing on the side, not a big deal at all, but the maximum width I will use now for my stand is going to be the same as the width of the rack, rather than the rack plus the width of the wood. It's going to look so much better if I do that, and it will also take up less space. Win-win. A little bit more work, of course, but not necessarily so much more. I'll just need to put a little cut into the side to make it fit. It'll be very easy, actually. So that's it for today. Thank you for watching, and goodbye for now.